Hello everyone, hope everyone is doing well. Today we're going to talk about probability. We're going to learn about different concepts of probability, and we are going to see examples of simple probability, joint probability, and we're going to look at some formulas to understand these probabilities. And finally, we are going to look at conditional probability. So let's start with simple probability. Let's first try to understand what is probability. So probability basically is a number between 0 and 1 that tells us the likelihood of an event. So what it is telling us is that if a probability of 0 means that there is no chance of it happening. Now very few, and 1 means there is almost, basically, or we can say it will most definitely happen. Very few events actually have a probability of 0 or a probability of 1. One example of something with a probability of 0 is maybe something like a person who was not born in the US becoming the president of the United States. That probably has a probability of 0. On the other hand, probability of 1, the only two things that we say have a probability of 1 is death and taxes. So we have to pay taxes, and if we're alive today, we will most certainly meet death sometime in the near future. Now, when we're looking at a probability, we can talk about different examples of probability. Starting with the very simple case and then building it up. So let's say we always start with a very simple case. Let's say we have a dice that has a 6-sided dice. So you have numbers 1 through 6 on that. Now, if it's a fair dice, which means that since there are 6 sides to that dice, and the dice will show, if I roll the dice, it's going to show 1 number. It's very unlikely that the dice will stand on its edge or in the corner. It's probably going to land on one of the sides. So let's say the total number of occurrences is 6. And a unique occurrence that will happen is what we will have. So the formula for probability is going to be, if I write it in a nice way, so probability equals number of occurrences divided by the total number of occurrences. So if I look at this formula, what it tells me, let me make it a little. So what this is telling me, it's if the total number of occurrences is going to be 6 in our case, and if I want to know what is the probability, so what is the probability I roll a 2? So if I count my dice, there's only 1 occurrence of 2. So the probability is going to be 1. That is, the numerator is going to be how many times the number 2 shows up, which is just once, divided by the total number of occurrence, which is 6. So I get my probability will be 0.16. Now, if I write something, what is the probability that I roll an even number? Now, in that case, I have 3 even numbers, 2, 4, and 6. So then the probability is going to be, there are 3 even numbers out of a total possibility of 6 numbers, one on each side of the dice. So I get a probability of half. So in this way, we can see that probability, just a simple probability, is just what is the occurrence happening and divided by the total number of occurrence that is possible. Now, this was an example of simple probability. Now let's look at a table, and let's look at something that we may call joint probability, and then some other examples of probability. So let's think about, let's say we have 3 factories. So we have factory A, factory B, and factory C. And they produce a number of items. Now let's say some items are defective and some items are not defective. So in each factory, we have a daily production or an hourly production, and our numbers are as follows. So in factory 1, we have 300 defective items produced and 1,100 non-defective items produced. In factory B, let's say it's 300 and 1,200. In factory C, it is 500 and 1,600. So then my total production for each factory is going to be, so for factory A, it is 1,400, factory B is 1,500, factory C is 2,100. And across all factories, my total is, I produce 1,100 defective items and 3,900 non-defective items. But the total is 5,000. So a simple probability would be, let's say, so if I randomly pick one item, what is the probability that it was made in factory A? Now the total production of factory A is 1,400. There's a total of 5,000 produced. So I will say it is 1,400 divided by 5,000, which is 0.28. So if I randomly pick one of the output, there's a 0.28 or 28% probability that it was made in factory A. Now, if I do the same thing for factory B, I will say that, well, there's 1,500 produced in factory B. So it will be 1,500 divided by 5,000, which comes out to be 0.3. So there's a 30% probability that the item was produced in factory B. And if I do the same thing with factory C, if I randomly pick a item or an output, what is the probability it's from factory C? So I will say it is 2,100 divided by 5,000, which comes out to be 0.42 or 42%. Now, if you notice something, if I added these three numbers, they will add up to 1. So which means because all these three numbers add up to 1, so these three probabilities should add up to 1. Now, if I use a little notation, I will call this probability of A. So it was made in A, probability of B, and probability of C. The other probability we have is called the complement, which means that it is not A in our case, or in this case, it would be not B. And we normally show a complement by a little, like an apostrophe on top or next to the A. Now, in our case, if I say probability of not A or not produced at A would be equal to probability of A prime. Now, in our case, since 28% or 0.28 were produced in A, so not A would be 1 minus 0.28, which would be 0.72. So the same thing, I would say probability of not B, or the complement of B, would be 1 minus 0.3, which would be 0.7. And so the probability of not C would be 1 minus 0.42, which would be 0.58. So probability of not C, which is 0.58. Now, if you notice, sometimes I'm writing probability as prob and sometimes as P. So it's up to you, basically, however way you want to write. Some people like to write it this way. Some people like to write it this way, but I mean, both of them are correct. So this goes with simple probability that we have done, and we also have looked at the complements. Now, the other probability, we can also find what is the probability of defective. Would be, I have 1,100 defective out of 5,000 productions. So it would be that number. So 22% of my output is defective. And probability of not defective, since these numbers are, the product is either defective or not defective, so we could actually say they're complements of each other, but we can also find it out ourselves. So we will find that it is 78% of the numbers are not defective. Now here comes another definition. So we would say that since, a product is either defective or not defective, we would call these two events, so defective and not defective, are mutually exclusive. That means if one item is in A, it cannot be in B. Or in our case, if it's a defective item, it's a not defective. It cannot be not defective, or vice versa. So in our case, then we can also write, the mutually exclusive is probability A and A prime, or complement of A, are mutually exclusive. If something has been produced in factory A, it cannot be produced in factories B or C. Now from here, we can see that. From here, we can now move to another type of probability, which we call joint probability. Now, joint probability is when two or more events happen concurrently. So it would be probability of, we would say, A and B happening together. Another way of saying it or writing it is in a more mathematical form would be, this is a joint probability, but it is also telling us what is the probability that A and B are both happening concurrently. So in our case here, we can also write this as A and B like that, or AUB if you want to write it. So let's look at an example of joint probability here. Now, let's say, what is the probability that something is from factory A and not defective? So in that case, I will look at factory A's column, and this number 1100 is fulfilling both of this. So I'm producing it in factory A and it's not defective, divided by the total number of occurrence, which is 5,000. So I will say equals to 1100 divided by 5,000, which gives me 0.22. So that will tell me that if I randomly pick up one of the output, the probability that it was produced both in factory A and not defective is 0.22. In other words, now I can do the same thing for factory B. So if I say probability that something was made in factory B and not defective, then I would do, the number is 1200 divided by 5,000, which comes out to be 0.24. So, and then the same thing for factory C. That would be equal to 1600 divided by 5,000, which comes out to be 0.332. Now, one thing here, if you notice, is that the total number of not defective is the sum of, all these three numbers, which we get to be 3,900. If I find the probability of not defective, I've done that before, but let me just write it up here again. Then you will find it's going to be 3,900 divided by 5,000, which is 0.78. And if I add these three numbers together, so if I add 0.22 plus 0.24 plus 0.32, I get 0.78. You see those two numbers are exactly the same. From here I can say, if I write, let me write non-defective as ND and defective as D. So just to make it easier. So we can also write this as probability of not defective and produced in A plus probability of not defective and produced in B plus the probability of not defective and produced in C. This will all equal to probability of not defective. And this is another formula that we have for statistics. So we can say, if there are two events, then I can say that probability of A given B and B1 happening together plus the probability of A and B2 plus the probability of many others plus finally the probability of A and let's say Bn, that's the last one, will equal to probability of A. So we can add probabilities across. The other thing that we see, so this one, as we said, is joint probability. We have two things happening together. So we can also do the same exercise with probability of being defective, and we can find that if I added the probability of A and defective and probability of B and defective and C and defective, then it would total equal to probability of defective. Now there's another probability that we talk about. This is joint probability. The other one we have is what we call a union of probability. So we say it's probability of A union B, which means that the probability of either A or B happening. In the previous one, it was either both A and B happening at the same time. So one could be that, let's say, what is the probability that I pick a product and it's either made in factory A or factory B. So if it's made in either factory A or factory B, I can see that factory A has 1400, factory B has 1500, and the total is 5000. So I can just add those two. In our case, because A and B are mutually exclusive, that is, if I produce in A, I don't really produce in B, so then we will say it is going to be equal to, probability of A plus probability of B minus probability of A and B. Now in our case, because we said that producing in factory A and in B is mutually exclusive, so we said probability of A and B equals to 0, so that's why we can say that probability of producing in either A or B equals probability of A plus probability of B. So let's say, we have all used Venn diagrams before, and so let's use another example. So let's say this is all events happening that could happen in A, and this is all events that could happen in B. So now, if I said probability of A and B, that is both happening at the same time, it would be this shaded region, okay? Now, because there is overlap, so if I write probability of A or B, I can see it will be equal to probability of A, because we want to include all the things in this side, all of A. Then we want to include plus probability of B, which then includes all this events in B. But if we include both A and B at this time, there is a double counting here because this part is included in A and in B. So we have to subtract probability of A and B. So this is the formula. Let's look at an example. Let's say A includes all the cards from 2 to 10. So all the cards that we have in a deck of cards from between 2 and 10. And B, event B, is basically all the spades in a deck of cards. So basically they would include A, 2, 3, and all the way to Jack, Queen, and King. So these are our cards. So A has all the cards from 2 to 10. So we have 4 different suits. So if we include all the cards, we have 9 cards. So we have 9 times 4, which is 36. So then if I were to draw a Venn diagram for that, let's say I have A, this has 36, but some of them are in B. So out of the 36 cards that I have, I see that the even numbers and spades, so B is that, and so the middle part is A and B, which is basically spades and between 2 to 10 numbers. So then we have 9 cards here, and so we have 36 minus 9, which is 27 cards left over that are exclusively in A and not overlapping with B. And B now has the other cards, which is A, Jack, Queen, and King. So now if I were to find what is the probability of, and this A is ace, not the other A. So now if I were to find the probability of A happening or B, so there are 52 cards in the deck, so that would be probability of A, which is going to be 27 divided by 52, plus the probability of B happening, which is going to be, there are 13 cards in a deck, so it's going to be 13 spades in a deck, so there's going to be 13 divided by 52. But now 9 of them overlap, so we have to subtract 9 over 52 from that. So eventually, if I write it up, it will be probability A union B would be 27 divided by 52 plus 13 divided by 52 minus 9 divided by 52. And the reason we subtract the 9 is because we have some cards that are common in both these sides. So we need to subtract one of them, or subtract from one side, so that there is no overlapping and overcounting. So if I were to find out this number, it would be 27 divided by 52 plus 13 divided by 52, which would be 0.596, so around 0.6. So from here, we can then write probability of A or U, B. In our case, the formula would be probability of A plus the probability of B minus the probability of A and B. And so in our case, the probability of producing in either factory A or factory B, since there is no overlap, so in our case, probability of A and B will equal to 0. So the probability that, if I pick a random item, it's either produced in factory A or B would be just the probability of those two numbers. So of probability of producing an A and probability of producing B, which is 1400. 1400 divided by 5000 plus 1500 divided by 5000, which gives me 0.58. Okay. Now from here, finally, we have one last type of probability that we talk about, and it is conditional probability. Conditional probability usually means that if some event already happens, then what is the probability? So it is something we update, basically, given all the information that we have now. So let's say that in our case, with conditional probability, we write it as probability of A given B. So this notation means that given that B has already happened, what is the probability that A is going to happen now? So let's say that in our case, we can look at probability of, let's say, defective given factory A, which tells me that given that we are in factory A, what is the probability So we are here saying that given that we are already in factory A, we're just dealing with factory A, what is the probability that the product is defective? So we are just going to look at these numbers. We are not going to consider the total anymore. Or in other words, what we will do, the formula for probability of A given B is probability of A given B equals to probability of A and B divided by the probability of B. So if I look at this formula and if I plug in all the information that I have, so we were looking at what is the probability that given that we are already in factory A, what is the probability that we have defective items? So it will be probability, let me just copy this over. So our formula is this, and let us work with that. So if I rewrite it this way, so it will be probability that a factory is defective, that I have defective product given factory A. So probability that my product is defective, I'll just write D for that, given I'm in A, factory A, equals to, I'll have probability of defective and factory A divided by probability of that I've produced it in factory A. So this is going to be my formula. So the probability that it is D and A, so defective and produced in factory A, so it is going to be 300 divided by 5,000. So let's write that here. So this is going to be 300 divided by 5,000, which comes out to be 0.06. And then we have to find what is the probability that if I pick an item or if I pick a product, it was made in factory A. And we found that already it was, the total production is 1,400 out of 5,000. So it will be 1,400 divided by 5,000, which comes out to be 0.28. So then I can plug this in. It would be 0.06 divided by 0.28, which comes out to be 0.214. And so this is telling us an easier way of working is that if I were to look into just factory A, this is what the probability of defective is going to be. And I can do the same thing with other factories. So let's say, given that I already have a defective item, what is the probability that it is from factory C? So let's say we want to find this, given that I already have a defective item, what is the probability that it is made in factory C? So in that case, if I write it up that way, probability of factory C, given that it is already defective. So if that's the case, then it will be the numerator will be probability of C and defective. So I'll just write D here, divided by the probability that it is defective. So the probability of C and defective is, if I go up here, it's factory C has 500 defective out of a total of 5,000. So we will write 500 divided by 5,000, which is equal to 0.1. And then we will write probability that an item is defective if I pick a random item. So the total number of defective I have is 1,100. So I will write 1,100 divided by 5,000, which is equal to 0.22. So then if I plug it in here, it's going to be 0.45. So given that I already have a bunch of defective items. What is the probability that it was from factory C? And I can find that out. It is 0.45. So this is conditional probability, and it usually happens if, like, basically we're dealing with a universe where we are already in this zone. So if we are in this zone, how do we find out the probability that a product is from factory C or B or A? Hopefully this was helpful. If you have any questions, please feel free to write in the comment section below. Have a good day, and I'll see you at a later video. Goodbye.